Hi. Now section 1.4, graphing with software. As the title says, computer software can be used for graphing, visualization, but it can be used for solving equations and analyzing data. In engineering, a major tool is programming. So you have to understand computer programming. For that, you may use Maple, Mathematica, Matlab. They are not in public domain, so it's not free. But if you try to use Python, that will be free. And here, for simple work in calculus, you may try to use online graphing software. For example, GeoGebra is available and you can get really good result. And along with that, and graphing and also differentiation and integration can be done quite easily. When you try to learn a computer language, then try to choose a very simple language. If the computation language is complicated, then it requires more time to understand the software, which means you may ignore, you may have some problem with your logic. Programming, major part of the programming is logic. So try to choose really simple language like Matlab and focus on the logic. Then you can be much better in programming. So being a good programmer would be quite advantageous in your career. Okay, let's see example with Mathematica. Mathematica is a symbolic software and very traditional. And in modern society, for symbolic computation is most popular. However, it's a little bit old-fashioned, and now here, as you can see over there, a little bit traditional. And personally, I'm not using Mathematica. Okay, also Maple is also available, and but with Maple, you have to import the packages, and by using command with and plot package and student calculus 1 package are imported, and inside the plot you can find the plot, and by using plot command, now here we made a picture for sin x. Okay, now later part, that one is how you can use for differentiation. You learn that later on. Okay, if we play with Maple a little bit more, then here now implicit plot for that circle, and implicit plot along with the polar coordinate, and now here, and also we define G as a piecewise function, and here we have a plot. So there are 3 plots which are made by using this simple script. Quite easy to use it. How about Matlab? In Matlab, it's basically numeric the software, so that of course you can do a symbolic computation nowadays. Now, first we try to make from -pi to 2pi and 100 points equally distributed. That is x, the collection of points. And for the point, we are making y value from sin x. So for x, y, and r means red, color red, and line width is 2, and grid will be added. So that later on we make such kind of a picture. It's made by using Matlab. Okay, and then ticks. Here now we put here -pi, 0, pi, 2pi. The tick is now that is given, and also y directional tick. is selected by the user, and title is also given. And here, when you try to save the picture, and sometimes you don't need outside of the figure, so that try to make axis tight, so there's no extra box, bounding box. And now this is saving part of the figure. And now here I'm using here now Octave, so that once you are running Octave, then inside of the program, Octave config info will be defined, so that if this variable exists, then this program understands that the user is using Octave, so that using that command else, then now it's Matlab, so that that is Matlab. Here Octave is free version of the Matlab, so that if we say the Matlab, then it is including also Octave. You can download Octave and use it. Okay, we'll see one example here now. For that one, okay, I opened Octave here now, and okay, let's go to the directory of the program. That is exactly now y equals sin x dot m. So you saw already from the lecture note that manuscript. And you can run this one by clicking run, or just to F5. I'm hitting F5. Then, as you can see here now, that picture appeared. Okay, in this way, you can run it. Also, this line is executed rather than that one. Now, sometimes, and Octave and Matlab has a little bit of difference. However, major part of the computation will be the same. And now, that one, the command is not built in Octave. And of course, here, the Matlab has a print command, so that you can use print only one command, so that you can save your figure exactly the same way. However, anyway, I'm now showing you how to use Octave rather than Matlab, but you can do it exactly the same way. Okay, so Octave is a free alternative to Matlab, so that you can download it and use along with this GUI, very good GUI. And here, if you go command window, then here it says that it is that is executed. So that's the vision you can see here now. Okay, that is one example. And also Python. You may use Python, and Python is really fast-growing language, especially in machine learning and AI area. If you want to work on that direction, then you have to understand Python. But Python is quite similar when you try to use, in particular, NumPy. We import NumPy with the name NP, and also for plotting, here now, PyPlot is imported with the name PLT. So here, NP linspace, earlier we saw this linspace from Matlab. Now we have also linspace. This NumPy is made mimicking Matlab, so that Matlab users can move to Python very easily, quite similar. Now, so we made this one, and X is made, an array of points is made, and then by using the sine function, built-in NP, so NP dot sin x, so that y will be made. The execution after execution of Matlab and here Python, in fact, basically these two arrays will be identical. Okay, now plot also the same, and plot package, so the plt dot plot, but it's the same as that one. And now we are putting grid, and also by using some options, green, and line style is that one. That is a dashed line, and line width is 0.5. And now plot x ticks and y ticks, and plot title. So it's almost the same. If you want to see the picture, then you have to give this command plot.show, then it'll appear. But now by using save feed, I saved that one, and along with here, finally, the bounding box is very tight, and so that the result will be that one. This is coming from Matlab, that is coming from Python, and similar window and similar output, so that you can use Python quite easily. Okay, here now you can solve these problems and by using software, and you can use any language. Just from the lecture notes, you can make a copy paste and put it in one file. For example, the same file name. If you are using Octave, then copy paste this portion and save it into in the file name. But if you are solving some other one, then you can name other way, and then adjust whatever required. Then you can get the plot quite easily. You can do that. Okay. That is end of section 1.4. Okay. Thank you.